everybody. So my name is Mark Larive, and I'm Business Development Director for the Exosens Advanced Imaging company. So it's probably a new name for some of you. Just to let's connect the dots. Exosens is the group name of what now Xenix is part of. So you probably more know the Xenix name, which is a company involved in shortwave and longwave cameras and sensors, with long history in food and agriculture and technology. As previous people said, typically we are a technology supplier. So just to help you understanding who we are, so Exosens, we are an innovative company, and we are dedicated to amplification, detection, imaging technology components, for safer words. So we are, let's say, big medium company, around 2,000 employees all over the world, with just a bit less than 400 million euro. And yes, we are really around the world with more than 70 countries, very technological oriented. And we have four main segments: life science, industrial control, nuclear sensor for nuclear plant, and an activity in defense. The group itself is 85 years old. So let's focus a bit more. Today, the purpose and the activity is typically in between life science, environment, and industrial control, because it's a control application in environment and life science. So it fits exactly in our segment of application. So for the business unit Advanced Imaging, we do cameras and sensors with, at the end, digital information. So we are located all over the world, but the main part is in Europe, with the headquarters of the business unit in Leuven, in Belgium. And what we do is sensors and cameras from the UV, including lower than 200 nanometers, up to long wave. So we really provide the technology. The use of it is for plenty of application and semiconductors, but also a lot in food and agriculture industry. Again, we make the sensors and the camera. Typically, our policy is not to compete to our customers, so we stop at the sensors and the camera, but we provide technology for hyperspectral imaging, spectroscopy, and so on. But our contribution there is just a sensor. The spectrometers, such as people of Ocean Optics, is one step ahead. It's not us, but our scale is really the sensor and camera. So where are we, and where could we be in agriculture and food industry? So let's say three main kind of application. All what is global vision, aerial vision, or it could be unmasked also. But for us, it's typically global vision. And here we focus on system on cameras that are compatible with a small payload. So typically it can be integrated in drone. So here we have some shortwave product and some longwave product, depending on what you want to see. Then we have also an offer dedicated for quality monitoring. So here, again, mainly in shortwave, but for here we are more in machine vision and control industry, with shortwave spectroscopy and shortwave hyperspectral. And we see that hyperspectral is more and more the trend, and several people before me already talk a lot about that. And then also for the food sorting and grading, so it's after. Here we provide system for or sensor for SWIR imagery and SWIR spectroscopy and hyperspectral. So first of all, global aerial vision. So what is the benefit with a shortwave? So it's typically the monitoring and of the health of the plant and what you want to grow, and detection of disease. So here again, our goal is to provide cameras that are compatible with drones so that you can fly over your field and make the detection. We do that in shortwave, also in long wave, because long wave is used for typically water stress measurement. And again, it's even more compact in shortwave, so in long wave, excuse me. So compatible with smaller and smaller drones. If you remember years ago, everything was done by planes or helicopter. Now, thanks to the evolution of technology, it's compatible with small drones. And to be compatible with small drones, the main requirement is to have something small, a camera which is small, which is light, which is not very power demanding. So what we call swaps, size, weight, and power optimized. So here we have different kind of camera. In shortwave, we have VGA camera, high speed camera up to 300 Hertz, the full VGA frame. So the resolution gives you an accurate registration. So it increases the precision of your measurement and thus the treatment you will apply. So at the end, you will reduce the chemical quantities and you optimize your cost. Because it's very sensitive, because we choose the kind of big pixel, 20 micron each, so you get a lot of light on each pixel. So you increase the sensitivity, and because you increase sensitivity, you increase the performance of the detection and the yield. And because it's compact, you can integrate it on a drone. So it's really drone compatible. We also have a smaller, an even smaller camera here, which is ultra swap. So you can put it on an even lighter drone. Okay, because it's smaller, it's because the pitch is smaller, so it's a bit less sensitive, but it's still very highly sensitive. So you can again have a very, let's say, accurate trace detection. So that's for the shortwave cameras. Then we have the long wave cameras, and here definitely we are speaking about ultra swap. So VGA to SXGA, so that means from the TV format to the megapixel resolution. So you can get very high resolution with this. Easy to integrate, shutterless. It's at the end, it's compatible with different kind of environment. It's very swap. When I say swap, just to give you an order of magnitude, we are speaking about some grams, some milliwatts. I think it's 700 milliwatts, 10 grams or something like that, with a size of 20 by 20 millimeter by less than 10 millimeters. So it's really teeny. So you can integrate it even in a small game drone, let's say. And it's very easy to integrate because it has been designed for that, and it's compatible with the machine vision interface and with a standard interface. And then we have the microcube, which is even smaller than that. Then for the application of quality monitoring, here the goal is more to make spectroscopy or hyperspectral imaging to really measure the chemical content. It's not just imagery, it's much more than that. And we have to design, and we design some specific, again, technology, sensors and camera for that. very sensitive, very small, so that you can even operate it on the field in a portable environment. So again, the side of the environment is our customer decision. We provide the technology which enable a very small system. And for SWIR hyperspectral, here it's the best of both. You have both the imagery and the spectroscopy. So you can measure the chemical content at each location. So let's say the first one is more a point measurement that you have to scan. The second is really an imagery. So here we develop some line scan, very small system for spectroscopy. So really dedicated for spectroscopy, rectangular, small, compatible with micro spectrometer, really portable equipment with specific features that are relevant for spectroscopy, so that typically you can adapt your dynamic depending on the level of your signal in real time for sure. You have an additional feature to even increase your signal to noise ratio to get a better detection and to really be able to say whether, yeah, this is a good product, this is a bad product. So you can, in real time, on the harvest, or even during the harvest, say, yes, this is good, this is bad. Okay, plus some additional features which are interesting if you put in front of the remark from Therese. If I remember, she said we have to handle with too much data in the future. That's a limitation. One of the feature is to be able to select just the part of the data that you want. So don't register a full spectrum if at the end you only need 3 or 4 wavelengths or channel. Yeah, just register this one and focus on this one. So we provide solution for that. And then for the hyperspectral, here we are more speaking on 2D sensors and camera. And again, here what you need is precision, precision on the width to cover the wider size, and also precision on the channel, on the number of channels. So with a VGA, you have plenty of channel up to 512. So it's usually more than enough. And here it gives you, again, increase in precision, and at the end of the year, you will obtain. Very sensitive, because in hyperspectral, as it has been mentioned, you don't have a lot of light. So you are starving from light, and you cannot always put a big lamp, and especially, as you said, halogen lamp, it's more and more difficult, so you have to select it. So the light budget becomes an issue. So now we have solution very sensitive, even when you have few lights. And again, it's small, so that you can integrate in a compact system. And then the final step, which is when the food is almost ready, here you need to sort it, to say, okay, this is good, this is bad. So that's the first level of sorting. That's what I call imagery technology, where you sort the foreign object or the bad object from the real food you are looking at, typically gravel from grains. So that's a well-known technology, and here we have solution to make the imagery, and because of the contrast between the good and the bad, you can sort. And the next level, which is more and more important now, is to be able to grade. Somebody before my presentation mentioned that could be because of the price of the good that you have at the end, but it could also be because of the use. So depending, for example, on the meat, you can grade the meat, be able to say, okay, there is this percentage of protein, this percentage of bones, this percentage of fat, and based on that, you can say, okay, it will be at that price, but also it could be at that for that purpose. You can put it for pets food, or you can put it for human food. So typically that's one of the applications. And here you can do that thanks to hyperspectral technology. And again, here we have technology, we have sensors and camera that helps this sorting and this grading. So here it's for imagery, but usually you do that on a moving system. So either free fall, either on a belt. So just a line, a very fast line camera is enough. Square pixel here. But again, you need high sensitivity because you cannot integrate long time. You have to be in real time, so it has to be sensitive. Depending on the resolution and the width you want to measure, we have small line 512 pixel up to 2048 pixel for very high resolution or very large belts. And we have, as I said, very fast system running up to 256 kilohertz to full line. So here you can increase the throughput. You can also imaging multispectral if you don't want to do real hyperspectral, but with multiplexing different LEDs. And for sure, we can adapt the gain, the sensitivity, signal to noise to the signal you are looking at. And for hyperspectral, here we usually provide 2D array cameras, so classical camera, VGA format. And here again, sensitivity is key. The format 640, 512 to get enough width and enough channel, and the speed. The speed here is key because you are looking at a push broom usually, and or let's say whatever the technology you use. You need to run at very fast and very high speed to get at the end a real-time measurement. And the faster you can get, the better throughput you can get. So again, that's what we can offer, and that's the advantage you will get at the end on the agriculture and food industry. And that's all for me. If you have any question, I will be very happy to answer.